Okay, finally we're on 1.6, and it just asks you to start thinking about answers to these questions because you're going to be asked to basically to answer them in the write-up. So you look at that. How do the Euclidean distances compare to each other? Well, I go here and I look at this, and what you should find, I mean, I'm not trying to keep a secret here, but you should find they're all basically 5. Okay, and again, if you look at our picture, right, it looks like they're on a circle, and so everything's about the same distance from that Euclidean wise. Okay, and so yeah, you should notice that. And then the next question: how do the grid distances compare to each other? Well, I don't have many here, but you can see they're different. Right, 5, 7, 5, and you'd have to look up these others. You'll have them, but I think you're going to find they're different. And then how? Oh, it says how to. I'll try to fix that. It should be how do the grid distances compare to the Euclidean distances? Oh well. Yeah, I think what you should find is they're all at least as big. So, 5 and 5, 5 and 5, 5 and 7. And these should all be, 5 or bigger. And so we can answer that question. How do the Google Path distances compare to each other? Well, it's pretty clear that, those are going to be different. All right, there's a 7, there's 6.2. Those are going to all be different. It's not so clear here on the times, but we aren't quite there yet. Let's see. How do the distances compare to the Euclidean distances? And, well, they're all going to be at least as big. I mean, there shouldn't be anything that's less than 5 miles. And how do the Google Path distances compare to the grid distances? Now it starts to get interesting because I think you can even see here, right? Oh, the Google distance is bigger than the grid distance here, but look, it's smaller than the grid distance here. Oh, and you should get some mixed results in here. And so that's interesting, right? Is that, well, should I use the, when I'm thinking about grid distance versus Google distance, well, is one bigger than the other one? Not necessarily is one, so I don't know, right? They could be different. So that's finally, I think, a truly interesting result. It's somewhat interesting, right, that grid distances are always at least as big as the Euclidean distances, but here it gets really interesting, is that they one may be bigger, the other one may be bigger or smaller or whatever. Let's see. How do the Google Path times compare to each other? Now, in these first two, they're both 12. Really, they're both 12 minutes. Were they both 12 minutes? Oh, that's Osborne. That's 15 minutes. So we can see that that's not the same. But anyway, okay, maybe they were both 12 minutes. But yeah, we'll see they are not all the same. And then the next question is, where we go here? How do they compare to the path distances? So how do the times compare to the distances? And again, it should be interesting in that you should see that just because something is the same time doesn't mean it's the same distance. Just because something is the same distance, there may be some that are the same distance, doesn't mean they'll be the same time. And just because one distance is bigger than the other doesn't mean its time is also bigger, right? So these are very interesting. These don't match up so well. The only two that match up really nicely are Euclidean distance and grid distance, because I can tell you that whatever the Euclidean distance is, the grid distance has to be at least that big. That I know. Other than that, all bets are off. And, and so this is getting at that. What were we supposed to notice from all our technical work? This is what we were supposed to notice. And then finally, why might Google Path Time be the most relevant choice in looking at accessibility? Why, as we have these 4 columns that we might choose from, why choose from this column? And I'll let you answer that. Okay, so I'm going to save that. Okay, so that gets us down here through section 1.6. So there's section 1.6.